Very good morning. Today we will solve a problem on FIR filter realization using lattice structure. The problem is determine the coefficient Km of a lattice filter corresponding to FIR filter described by the system function h of z, and it is given by 1 plus 2 z inverse plus 1 by 3 z power minus 2. Also draw second order lattice structure. By looking into this, we can say that the order is n is equal to 2. Either they have directly given, or from this the highest power is 2. Here the highest power is 2. By looking into this, we can easily say that the order n is equal to 2. Now we'll solve this particular problem. So we'll take the given system function. The given system function is h of z is equal to 1 plus 2 z inverse plus 1 by 3 z power minus 2. I call that as equation number 1, and we know that in general y of z by x of z, which is h of z, is given by a of z. So here why a of z? Because we have only one numerator polynomial, that is equal to 1 plus summation I is equal to 1 to m am of I z power minus I. I call this as star. So what is the value of m here? M is nothing but order of filter. The order of filter here is 2. I'll substitute that. As a result, you will get a of z. As a result, you will get a of z is equal to 1 plus summation I is equal to 1 to 3. I is equal to 1 to 3 a m of I z power minus I. So what I'll do now here is I'm going to expand this particular equation. We're going to expand. I'll call this as equation number. I'll check which other numbers I have given. I have given 1, right? So I'll expand this particular equation number, that is equation number 2. So if you expand this equation number 2 for various values m, so we will get a of z is equal to 1 plus a, the value of the value of m is 2 here. It's not 3, it is 2 because it is second order system. So the order is 2, so that you will get the value of m is 2. So if you substitute that here, you will get a2 of, what is the first value of I? The first value of I is 1, z power minus 1 plus the next value of m is, so m will remain same, m is fixed, a2, the next value of I is 2, z power minus I, the value of I is 1, 2 now in the second case, so that you will get a2 of 2 into z power minus 2. So I call this as equation number 3. So in the next step, what I'll do is I'll compare 1 and 3, that is equation number 1 and 3. If you compare equation 1 and 3, see here, this is your equation number 1, this is your equation number 1, and this is your equation number 3. So if you compare, what we can observe from that here is a2 of 1, the value of a2 of 1 is 2. Similarly, the value of a2 of 2 is equal to, the value of a2 of 2 is equal to 1 by 3, which we'll use in the later stage. So we know that these are the formulas which we'll use in order to realize the given system using lattice structure, that is m varies from m minus 1 etc. till to 1, this is small m, and then km is equal to am of m, and the last equation is am minus 1 of I is equal to am of I minus am of m into am of m minus I divided by 1 minus km square, where I varies between 1 to m minus 1. Now since order is equal to 2, since order is equal to 2, So if I use this particular equation, then small m will take two values. They are m is equal to 2 and m is equal to 1. Now let me consider one value at a time. Let me consider one value at a time, and then I'm going to substitute the value of m in the given equation in the following equations. So if you do that, we'll get it like this. So I'll take one case 1, let m is equal to 2. Now check how your I will vary. Substitute here. So if you substitute here, your I will vary from 1 to 2 minus 1, which is nothing but 1. I will vary between 1 and 1, which is nothing but I will take only one value, that is 1. Now I'll use this second equation. As a result, what is second equation tells? Km is equal to Am of m. The value of m is 2, that is K2 is equal to A2 of 2. What is the value of A2 of 2? See here, the value of A2 of 2 is 1 by 3. The value of A2 of 2 is 1 by 3. Similarly, I'm going to use this value in the next equation, that is when m is equal to 2 and I is equal to 1. So what you will get, A, the value of m is 2, 2 minus 1 is 1, of I will vary between 1 to 1, which is nothing but I will take only one value, that is equal to A, the value of m is 2, of I value is 1, minus A, m is 2, A2 of 2, again m into A, m is 2 of 2 minus I, the value of I is 1, so that you will get A2 of 1 whole divided by 1 minus K m square, the value of m is 2, so 2 square. Now what I'll do is I'll going to substitute for them. If I substitute for that, we'll get what is A2 of 1, the value of A2 of 1 is 2, minus the value of A2 of 2 is 1 by 3, into the value of A2 of 1 is again 2, divided by 1 minus the value of K2. The value of K2 is 1 by 3, is 1 by 3 whole square. If you simplify this, you will get A1 of 1 as A1 of 1 as 3 by 2. Similarly, I have one more case, right? So I completed for m is equal to 2. Now I'll take for m is equal to 1. Now I'll take for m is equal to 1. Now when m is equal to 1, if I substitute that in this particular range, I'll get I will vary from 1 to 1 minus 1, which is 0, right? So I will vary between 1 to 0, which does not exist. This will not exist. As a result, I won't substitute that in this particular equation, but I can substitute that for here. So that I'll get K, what is the value of m? 1, Km, the value of m is 1, that is equal to A1 of 1. What is the value of A1 of 1? Which is 3 by 2. So from this we found out both the values of K. So since order of the given filter is 2, so I need two constant, one is K1, other one is K2. So I could able to get both the constant. Now by making use of them, I can realize that with help of lattice structure, and that particular structure will look like this. So I'm going to draw that lattice structure now for order n is equal to 2. So this is how lattice structure for FIR filter will look. Here we have constant K1. The value of K1 is how much? The value of K1 is 3 by 2. Similarly, here you will get K2. The value of K2 is 1 by 3. So I'm going to write that, and here you will get f2 of n, which is same as y of n. Here you will get r2 of n. So from this we can easily say that we could able to realize the given filter using lattice structure. Hope you have understood this particular problem. Thank you.